Hey everyone, welcome to 100 GB. This is the third episode of the Clean Code series. This series is all about the Clean Code book written by Robert C. Martin. And today we're going to talk about the third episode, which is functions. By the way, if you haven't seen the first two episodes of the series, the link is in the description below. And anyway, this video is part of that playlist, so feel free to check that out as well. Okay, what are functions? Function is a basic building block for any program or software that is written on this planet. Let's take a real example. So, this code is from the Android open source project. This class is called Notification Manager Service. We are looking into this method, and frankly, I'm looking into this method for the first time today. So this is real code which is actually running on your Android phones right now. And I think this method, as from the name and the implementation, it looks like this is the one which is responsible to buzz, beep, and blink the notification light, like whenever the notification arrives. And by the way, you can also consider the example in the book. That is also good enough. Let's have a brief overview of the code. The name of the method is buzz, beep, blink, logged. It takes in a notification record, and then it checks something on the audio manager. It sees if the device is on silent mode, and not in silent mode, then it does something. From the looks of it, it looks like it plays the sound. Then it checks if the notification record has should vibrate property. In that case, it vibrates the phone most likely, and there is this running boolean, either if the sound is played, or if the mobile is vibrated, or if the notification light is pulsed. This remains true. And then finally it sends some kind of callback. It's more like it's calling this function or a runnable after this much delay. That's it. Okay, let's get to the first topic for today, that functions should be small. In this code, it's very apparent that this function is particularly very long. Let's try to shorten it up by maybe breaking it down into further functions if possible. Okay, from the looks of it, I feel that this particular part can go in a separate function altogether, very similar to how they're using the vibrator to vibrate and the whatever attention light to have this pulse kind of thing. Okay, let's quickly. Okay, now the function is supposedly more readable in the sense that it's very clear now what this thing is doing. It's probably playing the audio and returning some boolean whether or not the audio was played. It's not still in a very good shape, but it's certainly better than before. Now, one question you might have is how small the function should be. Well, there is no silver bullet over there. The functions can, the book suggests that it should be either 3 or 4 lines. I personally feel my sweet spot is somewhere around 7 or 8 lines. Let's get to the next thing. A very nice quote from the book, that functions should do one thing, they should do it well, and they should do it only. Let's take a look at our code and what we did earlier. So we encapsulated all the audio playback related code inside this play audio function, because of which there are two good things that have happened. One is that this function is now smaller in length, as in the buzz feed, the main function itself, and we have a new function which is also small enough. So yeah, so far we're going good. Well, the other thing that the book mentioned is that functions should have just one level of abstraction, or kind of one level of abstraction per function. So what it means is, if you take a look at the previous version of this function, okay, so when the reader is reading this code, first 3 lines are fine. The reader is projected with this deep level of tech information. There is something called a binder. You need to clear the identity, then you use audio manager to get the ringtone player, then you call play async method on the player to play the sound. But when you see the other part of the function that says just call a vibrate method on the vibrator, no need to clear the identity and stuff like that, it looks like this level of abstraction is certainly different than the level this particular logic has. What we did is we encapsulated it into a separate method, and it looks like this thing here is now starting better in that sense as well, because if we see the abstractions, it's kind of the same level. We're not going deeper into what things are or how they are getting called. In some sense we are doing that over here, but this can be improved even further, and let's do it right away. So one thing that is still funny is these if conditions. So if you see the if conditions, okay, on the first if condition, It does a lot of things which may not go well with this one, and not even this one. So if we talk about this one in particular, it checks if the record itself has this should vibrate property. It may or may not be a property, by the way. But over here, it actually relies on this logic that if the light is not null, then start the this pulsing thing. So one thing over here we can do better is maybe add a new method in the record itself, like should do light pulse or something. So again, it's a matter of abstractions. This method shouldn't care about what kind of logic decides whether or not it should do the pulsing or the vibration. And similarly for the playing audio as well. But here it's a little tricky because if the phone is silent, the notification record might not know about that. So the next best thing that we can do is let's add a new method. Okay, now if you see the abstractions in all these three if conditions, they look very similar. If it can play audio, then play the audio. If it should vibrate, then vibrate. If it should do light pulse, then pulse. And we can do even better. Alright, so you see what I did there? I added three methods, maybe play audio, maybe vibrate, maybe do light pulse, that actually do nothing but just check for, they just check for whether or not this particular thing should be done. They do that and they just return true. That's it. So if we now look at this method, it kind of seems perfect now. The reader comes here, it sees, okay, if any of these vibration, audio, light pulse was done, then this is true. And when this is true, in that case, a callback or whatever, some method is called after this much delay. And well, this is not a working code. I know I have to pass notification record to maybe two of the methods, but yeah, that is fine. You guys got the gist. Okay, so the next thing that the book mentions is the step down rule. It is actually more in line with how you read code. So whenever someone is reading code, they actually start from the top, and the code should be written in a way that it is optimizing for that top to down reading. Think of it like the more down you go, the more level of abstractions you uncover, and which is actually true with this function. If you start reading the code from the top, you see that if the reader wants, they can actually go into the implementation details. But if they just want to take a look at a higher level on what this function is trying to do, this is enough. Like, that's all. You don't, if you want, you can, but otherwise you should be good, or the reader should be good. And that's how all of this ties together under this umbrella that the functions should do one thing. Okay, let's switch gears and proceed towards the switch statements. Now, switch statements are very hard to squeeze down. Well, a statement with even 4 cases is like decently large, not very, but 4 cases, and if each case has like at least 3 lines, it'll become around 12-13 lines, which is slightly bigger, and frankly it's like unreasonable to get rid of them, or it's very hard. So let's take an example from AOSP again. Alrighty, this is this Wi-Fi configuration class, and it has some authentication algorithm as far as the Wi-Fi is concerned, some open, shared, and leave. I'm not sure what this really means. So yeah, it's effectively an enum here, and they have a switch statement over here. Method says get auth algorithm. It gets an integer value, and corresponding to that integer value, it returns that particular enum. Well, it looks fine. Like one small I won't say optimization, but just for the sake of reducing the length of this method, what can be done is you can use a hash map to map this like integer value of the algorithm to the enum value, and just query that hash map whenever this method is called. For most of the cases, it should be fine. Okay, but for cases where the performance is super critical, like maybe maybe in this case, if this method is called by multiple applications a lot of times, then maybe in the view of performance or lesser memory overhead, this is fine. And let's take another example from AOSP again. This is called activity manager service, and this method is called whenever an app dies on the phone. So let's say you're using Instagram and you were creating a story and the Instagram app crashed. So this is the method which is called like inside the OS. I forgot to mention, so all the code that you are seeing here is actually inside the Android operating system. It's not the application code, because as you see, it's a service which is like at one layer deeper than the applications. Okay, so this method is called, we have a process record which probably contains some information of the application, and we see this switch statement which sees if the state of this process is some certain value. If the state is cached but empty or activity, or it's recent, then do something. If the process had, let's say, a bound foreground service, then just log and do nothing. Then if it's a foreground app, okay, check if the app is restarting or not, and then do something. And similarly for other switch cases. Now this is a case where it's very hard to actually get rid of the switch statement itself. Now there are some strategies which you can actually implement here. One is coming up with a class named cleanup algorithm and creating multiple algorithms based on what is happening over here. So let's say foreground app cleanup algorithm can be all the code which is happening over here. Like this particular code can go inside this class, and we can have a method that says cleanup. Okay, this is kind of the base class, and yeah, so this version of the cleanup algorithm can actually implement the code that we saw above. And similarly, there could be other classes which are implementing this cleanup algorithm and having their own cleanup methods. And at last, we come back to the hash map. We can create a hash map which maps this integer value to the required algorithm. And now this all of this can happen in just one line. In that case, you get the algorithm for after that is done, this is what this method will do eventually, just one line. It gets the cleanup algorithm for this app's UI state and then just calls cleanup and it cleans up. Well, it's not as simple as it seems to be. There are a lot of things here, but for the sake of learning this concept, we are fine. One nice thing about what we have done is we actually abide by this open close principle that says that classes should be open for extension but closed for modification. Because now what happens is, let's say if there is a new state and you want to add a new algorithm, what you would do is you will just create a new algorithm class. Okay, let's call it new cleanup algorithm, and then just add a new entry in this hash map, and that's it. So you actually didn't change your existing code. Well, in some form you did for this map, but that is fine. You just added a new class. Okay, the next thing is a function should have a descriptive name. So in the sense that function name is usually a verb, like do this, do that, get me this, process that, is it valid? It's actually a silver bullet. Like it's very hard to come up with a function name which is not a verb or a verb phrase. And if you do come up with such a name, that is probably a bad name. So a function should do whatever the name says. A very classic example is doing some fancy stuff in a getter. Let's take a look at the code. So we have this class employee, and which has a method that says get age in years. It has some synchronization over there, and then it does this weird stuff. It sets the age beforehand. Maybe it's getting from the network and then writing to the disk and then returning it finally to the client. But this method is assuming a lot of things which it shouldn't ideally, because it appears to be a simple getter which should simply return the that's it. It shouldn't do like other crazy stuff. Okay, so ideally if you are writing a method like this, you should make it very explicit in the name itself. Okay, let's try to rename it. Set and get age in years logged. Okay, you shouldn't be afraid of using like super long descriptive names. So the name now is pretty clear of what's happening inside the function. It is setting and finally getting the age in years, and logged, it kind of stands for the synchronization stuff that is happening over here. Now the gist of all of this is that functions should be simple and the name should reflect that. If they are not simple, again, the name should reflect that. Alright, the next thing that we'll talk about is the arguments of the function. Well, the ideal number of arguments for a function should be 0 or as the book calls it, niladic functions. And if it has one argument, it is called monadic function, and similarly dyadic and triadic. Well, the crux of the matter is that the more the number of arguments, the harder it gets for the reader to understand what the method is trying to do. And there is this thing called output arguments, which is even harder to understand if they are multiple. Actually, a lot of languages doesn't support that out of the box. You can still like return an array, and the call side can probably query this like the first and the second, third index of the array, which is kind of weird. Anyway, a couple of modern languages, they do support it out of the box now. I don't use it quite often. And there is this thing called flag arguments. Flag arguments are really bad. Let's take a look at the code. Let's assume there is this class called chessboard, which has a render method which takes in a boolean. Okay, if you, as a consumer of the class, you are not taking a look at the class, you are directly trying to call the method, and it will be something like this: dot whatever the object, let's call it just cb.render true. Now it's very hard for the reader to understand what is happening. What does this true even mean? That's the reason that these are like hard. Now, in order to make it more descriptive, you either use kind of a argument name in the form of comments over here, which is something that can be done. But again, as I said earlier, it's even better to be more explicit, which means it's even better if we do it like this: render on Android, and just remove this boolean altogether. Doesn't make any sense. And similarly, we can have other methods like render on iOS or whatever. Okay, let's take a look at some common nomadic forms of functions. All right, so it can either be of a question form, like whether or not this file exists or if this widget is visible, or it can be of an event form, like if some event is received, you have this method and that event is passed as an argument, as the only argument of the function. And the third case is like either transformations or conversions. So let's say you have a manager which is being promoted to a director. That's how the function looks like. Now, for dyadic and triadic functions, keep that in mind that if you have multiple arguments of the same type, it can lead to some weird problems on the call side. Let's take an example. So let's say you have this class Wi-Fi. Okay, this is another like real class from AOSP. So you have this Wi-Fi manager class which has this method that says set country code. It takes in the country code, whether it is persisted or not, whether the change should be notified or not, and if it's coming from a dialog, stuff like that. Now let's take a look at the call side. So you call this method set country code, and then you have this weird stuff going on: true, false, true. And trust me, it's very easy to replace this mistakenly. So let's say if someone is using this method and they have a local variable from dialog, they might end up using from dialog at the first place, which is actually supposed to be this persist argument, which means it's like wrong. And that is where things get really tricky. If you have multiple arguments of the same type, the recommendation here is to use a class or a container. And ideally, it's even better if you can use builder pattern with it. If you move these three variables into a class, let's call it maybe country or set country. So if you have a builder like this, which has methods for all these three variables, and you replace these three variables with an object of such class, now making a mistake like the one I just mentioned is very hard. So this is something which is not recommended in the book, but this is something that I truly believe in. So builder pattern, I hope today you learned something new. Okay. The next thing is that the functions should have no side effects. Now, what do we mean by side effects? Let's take an example. So we had this class called user validator. Well, this example is directly from the book, and it has a method check password, which takes in a username and a password as strings. Now, the first thing it does is it gets the user from the user gateway using the name. If the user is normal, then it gets some phrase encoded by the password, and then it uses the password which is coming from the client, and then decrypts the code phrase, and then matches if the phrase is valid password. Well, it should ideally just return true. Why is this over here? Now, if someone is consuming this method, they will never imagine that it will initialize the session for this user. So yeah, this is very weird, because if someone is calling this method, they won't assume by themselves that the session will be initialized as well as part of this method. So it's better just remove this and maybe have another method, another explicit method to initialize the session, which takes in the user object or whatever. Okay, the next thing we should talk about is try or don't repeat yourself. Well, I think I've repeated myself in this video quite a few times. Anyway, it's a very common code smell where the code that should have been encapsulated is actually repeated multiple times. And let's take an example. Okay, so this activity class is from some random Android application where it has a method that requests the permission. So if you've ever used an Android app, you might have seen that it requests permission. Like in this case, it's requesting for, it's first checking that if the camera permission is granted or not. If it's not granted, it requests for it. Similarly for contacts, location, and some storage. So we can see here that this particular logic is effectively repeated like 4 times. The only thing that differs is this location itself. So why not like encapsulate this in a function and call that function multiple times here? So if we add a new method which looks something like this, takes in a permission, checks for the permission, and then requests for the permission if it's not granted. Name it check and grant permission. And now things are quite simple. We can actually call that method 4 times with the different permission. Okay, so compare this with the previous version of the method. World of difference. And you don't need me to tell you that it's so much readable now. Okay, time for conclusion. As very evident from this video that writing code is like writing an essay or a story. You start basic in a scratch pad and then you keep massaging whatever you have written until it reads really well. So whatever we discussed today is mostly suited for Java, but can be applied to other like object-oriented programming languages as well. And make sure you use all the bells and whistles of the language, like whatever language that you're using. And yeah, write clean code, write clean functions. And this was it for this video. Okay, before you drop off, please hit that like button and share this video with your batchmates, colleagues, friends who are in the tech world. I'm pretty sure this series will be helpful for not just like the new generation of the coders who are coming in, while I'm not sure if it's helpful for AI. Anyway, maybe AI learned something from this video. Okay, so yeah, subscribe to the channel if you haven't already. I will see you in the next one. Bye.